Hello, hi, year 11 students. I'm still having connection issues. It's mainly because I'm using data and I do not have a Wi-Fi connection, as what I've mentioned already. And so I have no choice but to do a lesson recording, and then I'm uploading it onto YouTube. It takes about 4 to 5 hours to upload because that's how slow is my connection. But at least I get to do it one day before, and then I'll schedule it so you can actually watch it on time according to the LTS. Um, Now, okay, so the video is just to show that it's me. Today we're gonna finish up chapter 14. In our last Zoom session, we talked about the ion extraction, and then I also talked about the uses of metal, and we used PowerPoint slides for it. There's left only one part, which is the extraction of zinc. I'm going to talk about extraction of zinc, and then I'm going to do some questions, end chapter question, but it's not the questions from the textbook, it's questions from another book that I have. And then I will be expecting some homework to be done, and I'll be taking pictures of the question from the textbook and chapter. I'm not sure how many of you have your textbook with you. If any of you left the textbook in the school, no worries. I'll be taking pictures of the question from the textbook and I'll upload it into Google Classroom, and then you could just answer the questions. And our next week, Wednesday's lesson, I'll be going through your answers, but I would need you to do the questions and then mail it to me so I can check through. Okay, all right. I don't think you need to see my face anymore, so we're going to go straight into the lesson. Now, we're going to talk about, so this white screen is for me to scribble. Now, we talked about how iron is extracted, and we talked about why a particular way of extraction. Essentially, we have the electrochemical series, which reactivity series, in which we have carbon and hydrogen embedded in, and practically, if you still remember it, just a quick recap. I know by this time you must be really bored hearing it, but if you remember, is please stop calling me a cute zebra. Instead, try learning how copper saves gold. Now, essentially, this you can see the carbon's position is here, and of course the hydrogen's position here. Now, when we talk about purification of metal or extraction of metal from the ore, we have two ways. One is, of course, roasting it with coke. Coke is essentially carbon. Another way is, of course, electrolysis, which is the more expensive way because it uses electricity. Anything that is located above carbon, such as aluminium, magnesium, calcium, sodium and potassium, we will have to use electrolysis. No choice, because electrolysis, no choice because they are more reactive than carbon. Therefore, you cannot expect carbon to oxidize these elements. Then, of course, whatever located below carbon, that's basically this whole lot up to here. This we essentially just do blast furnace, which means you can extract them by burning them or roasting them with carbon. Silver and gold are practically inert, so generally we found them as native species, which means we find them quite pure in the nature due to the fact that they are inert. Now, I'm going to talk more about extraction of zinc. As you can see, zinc is extracted using the same technique. There's just one minor difference between zinc and iron extraction, and I will be going through that in a bit. So just want to give you an overview. Hang on, I'll just give us, do not have to save this. All right, now, same idea. When we extract iron from earth, it comes out as iron ore, and we talked about its name being hematite. Okay, so hematite is the name of iron ore. Now zinc, on the other hand, zinc ore is called zinc blende. Okay, so and then there's one more, which is lead, or has got a sweeter name, which is galena. Yeah, so it's good to know lead ore. You might not be able to find it in this part of the textbook yet, but yeah, it's not that difficult. Essentially, the extraction is exactly the same, one minor difference. Now I just want to give you a general concept. Now, unlike iron ore, in iron ore we find iron as iron oxide. In zinc ore and lead ore, we find them as sulfides instead. So it's zinc sulfide or lead sulfide. Therefore, they have one step that will have to happen before the blast furnace, which is roasting it in the presence of oxygen. So of course, what they do is they'll crush it, they'll crush these ores, and then of course they'll treat it under high temperature in the presence of air. Essentially what we want is for it to react with oxygen. Essentially what happens is zinc sulfide will react with oxygen, and that will give us zinc oxide plus sulfur dioxide gas. Now of course we need to balance this, so it's a 2, it's a 3, and it's a 2, and it's a 2. Okay, so you can see here the product here, the main product is zinc oxide. Zinc oxide now can be put through blast furnace, okay, which is very similar to the blast furnace process that we saw for iron extraction, and that should give us zinc. Of course, there's going to be a byproduct, which we don't have to talk about it yet. Here, this byproduct is something we have to talk about because this is an acidic gas. Okay, so acidic gas, which means you have to treat this carefully and carefully remove it from the factory, the smelting process, and this gas has to be captured in their chimney instead of being released into the environment, because it's an acidic gas. It can cause acid rain. Now, lead ore is extracted in the exact same way, the exact same process. Okay, all right. Let's look at the exact similarity and the differences between extracting zinc in the blast furnace compared to iron. So give me a bit of time. I'll save this. Don't need this. Right. Okay. So we're going to use this. Now, the image on the left that you can see here, on the left of the screen, is the blast furnace for zinc extraction. That's a snapshot from your textbook. And the one that's on the right-hand side is an extraction of iron, which is what we covered in the last week's lesson. Now, we're going to focus on the blast furnace for zinc extraction. Now, there is a few steps in which the reaction takes place. Of course, there will be carbon, coke. The coke is mixed with zinc oxide up here. As you can see, I'm just gonna circle that. So you have zinc oxide and coke. So essentially what will happen is as the hot air is being blasted into this mixture of zinc oxide and coke, you will expect coke to react with the oxygen to give us carbon monoxide. Hang on, yeah. So carbon monoxide. Now, this is important. We need carbon monoxide, not carbon dioxide, because carbon dioxide would become quite useless in causing the reduction of zinc oxide. Now, so you get 2 molecules of carbon monoxide. So we'll put 2 here. This carbon monoxide will be instrumental. What it will do is, obviously, you have your zinc oxide that's in this mixture. So I'm going to circle that here. So zinc oxide will obviously react with the carbon monoxide, and that will give us zinc plus carbon dioxide. Now you must be wondering what's happening, why, how is this different from the ion extraction? Essentially, these two equations are exactly the same as what happens in the ion extraction. The only difference here is the temperature inside here is high enough to cause zinc to become gas. Okay, so that's why you see here the term zinc vapor. So I'm gonna just circle that. That's because the temperature inside here is beyond the boiling point of zinc. So zinc becomes gas, vapor is gas, and that gas is gonna flow up naturally. Gas is lighter. It's gonna go up and enter this vent in which cooling takes place, and your zinc will become liquid, in which it could then be collected. So it's different on the right hand side. Now I just want to draw your attention to the right hand side. You can see how the molten iron forms at the bottom, because the temperature inside the blast furnace for iron extraction is not high enough to cause the iron to become gas, but it is high enough to cause the iron to become liquid. So we can easily extract it at the bottom as liquid, and in zinc extraction it becomes gas. But essentially what happens is the same. The balance 2 reaction, where the carbon dioxide will further be recycled. It can react with the coke to give us another 2 molecule of carbon monoxide, and this carbon monoxide can further react in the same reaction here. So this reaction. Another reaction that could also happen is direct reaction between zinc oxide and coke, which would give us zinc and carbon monoxide, all right, which then of course can further react with other zinc oxide. Now this reaction can be given in exam if you're asked to give how zinc is extracted from its ore, but keep in mind, zinc, when we extract it from earth as zinc blende, it is not zinc oxide, but it is zinc sulfide. So before blast furnace can happen for zinc oxide, zinc sulfide has to be roasted under high temperature with air, and the zinc sulfide would react with oxygen to form zinc oxide and sulfur dioxide gas. It's what I just explained before I move into this picture. All right, so these are the equations that I really need you to remember. You really need to remember how does coke react with air to form carbon monoxide. You need to remember how carbon monoxide will react with zinc oxide to give us gas of zinc. That's for zinc extraction. Please remember there's no gas of iron in the iron extraction. The reason why it is gas is because the temperature inside the blast furnace is higher than the boiling point of zinc. And of course, can coke react directly with carbon dioxide? That comes out of this process. So essentially this happens after this. Yes, producing carbon monoxide. Carbon monoxide, again, that means can react with zinc oxide. And then one other reaction that is sort of also happening at the same time is zinc oxide reacting directly with coke to give us zinc and carbon monoxide. And obviously carbon monoxide can again trigger this reaction back. All right, so please take note of these equations. I want you to remember this to be able to answer questions and for exam purpose. You can see on the right hand side, this is just a recap of iron extraction, is what we've talked about in the last class, and also you watched a video on this iron extraction. The video also listed out the equations. You can see how iron oxide, which is hematite, will react directly with coke to produce iron, which immediately melts due to the high temperature, and it collects at the bottom, in which we can directly shape it into whatever we want. Of course, the reaction could also mean a certain amount of coke will be mixed with the iron to give us steel that has different percentages of carbon. For that, please revisit the previous lesson. I'm also uploading the Zoom recording of the previous lesson in case if you missed it, or you couldn't hear parts because of the poor unstable connection on my end. You can watch the video back. I'll place the link to the Google Drive in our Google Classroom. Now I'm gonna go into questions. Hang on, let me just save this. I'll save that, and I'm gonna go to questions. Let's look at questions. Okay, not this. We'll look at this. All right, okay, some questions as a means of practice. Zinc and lead are obtained from ores that contain only the metal and sulfur. That's what I've mentioned before, in the molar ratio 1:1. So what do they mean by molar ratio of 1:1? If I write the formula of lead sulfide, which means it's 1 mole of lead attached to 1 mole of sulfide, or zinc sulfide. So 1 mole of zinc to 1 mole of sulfide. Now, again, why is it so? Because zinc has a charge of 2 plus, sulfide has a charge of 2 minus, so they occur in a ratio of 1:1. Same thing with lead, 2 plus, 2 minus, and it happens to be 1:1. So name the compound in these ores. So the compounds are lead sulfide and zinc sulfide. That would be the answer. Write down the formula. There you go. I've written it down. Oh, when they say name, you're supposed to spell it out, and you can't write the chemical formula. So for A, the answer will be zinc sulfide and lead sulfide. Okay. B, I've already done it here. And in the extraction of the metal, the compounds are roasted in the air to obtain the oxide of the metal. Sulfur forms sulfur dioxide. Right equation for the roasting of the ore. Now, this is standard questions. They will focus on what's happening during the extraction in terms of chemical reactions. So when you're studying, you have to try to remember the equations. That's how you get marks for this section. Right equation for the roasting of ore. If you remember roasting of the ore, this happens before we proceed with blast furnace, which means we take the sulfides and we convert them into oxides. So how do we do that? We react them with oxygen. So zinc oxide reacts with zinc sulfide reacts with oxygen to give us zinc oxide, and we get sulfur dioxide gas. And then try to balance it. There is a 3 here, and there is a 2 here, and there's a 2 here. Okay, so what type of reaction is this? So what kind of reaction is this? Simple. You can see there's oxygen here, and there's sulfur here, and the sulfur becomes sulfur dioxide. This is what we call as a reduction process. Because you can see zinc sulfide becomes reduced by the oxygen. So what type of reaction is this? This is called reduction. Okay. Care must be taken in disposing the sulfur dioxide produced. Explain why. Simple. It is an acidic gas. Okay. Can also say toxic. It's toxic for human and living organism. The oxide can be heated with coke, carbon to obtain the metal and carbon monoxide. Write equations for the reactions with carbon. Okay, so this is what we did in the just like a few minutes ago. Reactions with carbon. So we take essentially this is what we are gonna put inside the blast furnace. So zinc oxide, it's gonna react with, if you still remember, carbon. You do not have to give the entire works of the equation. You could just give one equation that gives us zinc, because the idea is we are trying to obtain the metal. So make sure you pick an equation that gives you the metal and carbon monoxide. To me, this is the easiest equation because I don't have to balance it. It's pretty straightforward. Okay. So which substance are reduced in this reaction? Well, obviously zinc oxide is reduced because carbon is oxidized, meaning it's gained an oxygen. You can see that's oxidized. Okay, all right, so this is the first question. So we've got 2 more questions to go for. Hang on, I'll save this so I could probably upload it, but it's in the video, so I'm not sure why I'm saving it. Anyway, so let's look at question 2. Okay, all right. So question 2, this table gives information about the extraction of 3 different metals. So we have iron, aluminium, and sodium. We can see aluminium and sodium is by electrolysis. So give the chemical name of each compound shown. So we're looking at chemical name each compound shown in this, because they gave us the formula. So you're giving it the name. So this is, the first one is of course iron oxide. The second one is aluminium oxide, and then of course the third one is obviously sodium chloride. Now if you're wondering how come they ask us such an easy question, well, it's standard because in year 10 you are expected to be able to name chemical compounds. So this is sort of the standard thing to be asked. Now common name for the 3 R's, well, this is called hematite. So the iron is called hematite, and of course the sodium essentially is called brine, but aluminium, and actually sodium and aluminium is no longer in your syllabus. If you notice, it's if you open the textbook, they no longer talk about extracting it. But this snapshot is from an older textbook that I have a soft copy of. So I think the only one that you really have to remember is iron, hematite. You can ignore brine. You can also ignore aluminium. You can ignore galena. I think the one that you have to focus is iron and zinc, hematite and zinc blended. That's the 2 that you have to know. All right, so arrange the 3 metals in order of reactivity. I think this one you could use your knowledge of the series. So if I'm doing order according to its reactivity, I think the most reactive in this case is sodium, followed by aluminium, and then comes iron. How are the 2 more reactive metals extracted from the ores? So obviously a method of extraction is already given. It's electrolysis. Explain why this is a reduction of the ore. Okay, the answer to this is simple, because the metal oxide undergoes reduction. Okay, so undergoes reduction. Okay, that's pretty simple. How is the least reactive metal extracted from its ore? Well, simple, using blast furnace. Of course, generally it's just 1 mark, so we could just say blast furnace. If it's 3 marks, then you have to obviously be a bit more detailed. You talk about how it'll be mixed with coke and then obviously heated at high temperature, so the carbon will reduce the R, which means accept the oxygen and produce pure metal. Explain why this is the reduction of the R. Essentially, it's the same question. I just realized it's repeating. Well, it means it's the same answer. The metal oxide undergoes reduction in the presence of coke. Why can this method not be used for more reactive metal? I think the answer is as simple as what we talked about before. Simply because more reactive than carbon, more reactive than carbon. Therefore, this is important, no reduction will take place. Okay, essentially, you're saying no reaction that will take place, but you are being a bit more specific when you use the word reduction. So which methods would you use to extract potassium, lead, and magnesium? So again, we will use the list. So potassium is electrolysis. Magnesium will also be electrolysis, and lead will be blast furnace. Okay, So gold is found native in Earth's crust. Explain what native means. Means unreacted. Okay. So you do not find it combined with anything else, which means you don't find gold in oxidated state. We just basically mine it, and then we clean it, and then we melt it and make jewelries out of it. Where should gold go in your list for B? Well, at the most bottom, last, because it's unreactive. Name another metal that occurs native. Silver. Okay. I think platinum can also go into the list, but platinum is not in your syllabus, so not really wise to talk about it. All right, I'll save this and look at the next question. I think it's the last question. So question 3. Okay, draw a diagram of blast furnace and show clearly how it is. Okay, first, drawing a blast furnace will not be in an exam of any kind, but in an exam they could give you a partially drawn diagram where you would have to complete either by labeling it or by writing something that's involved. So I'm going to do very, very basic drawing, very simple drawing. So this is iron. So we draw the setup for iron drawing. Simple, extracting iron. So I'm going to give a very simple drawing. Might be a bit hideous, but that's okay, as long as you get the point. So we leave a bit of gap there. The gap is mainly for movement or waste gases. So, and this, okay, that's gone a little too big. So it's challenging to draw with this device. Okay, right. So then we have this part where they would insert they call it the hopper, essentially, where they insert the R, and so okay, so essentially it goes down like that, and then you have an opening here to allow the molten slag to go out, and then here you have. So essentially there's different temperatures here, which is, I think it's not something you have to worry about, but I think the bottom part, which is 1500 Celsius, is quite important. So this is where air goes in. That's why it's pretty hot. So we can label as hot air, and then here is hot air as well. So hot air goes into the bottom part of the ore, and of course this is where slag comes out. So you can see label as slag, label as slag, and then at the bottom part here is where we collect molten iron. Okay, so you can label that as molten iron. Okay, not the best drawing, but get the idea. And then the waste gases go out this way. They either get recycled or used for something else. So that's your waste gases. Just let me think if I've missed out anything else. And of course, there has to be a way for the molten iron to come out. So you draw that. Okay, not the best looking drawing, but you get the point. Like I said, you do not have to worry about drawing this. Drawing is not a must, but you do have to know what happens in this entire reaction. So where is air blasted into the furnace? So as I've mentioned, it's blasted at the bottom part of the furnace. So the hot air will go up through the mix of coke and iron oxide. Where the molten iron is removed, it's removed at the bottommost part of the blast furnace. Where is a second liquid removed? It's removed right above slag. The reason being slag, it is less dense. It tends to float over the molten iron, so it is generally removed. It's the top layer. Once it's removed, what's left beneath is molten iron. Because of the difference in density, you can actually remove it simultaneously. Name the three raw materials used. Okay, three raw material essentially is iron, ore, okay, coke, and limestone. Okay, so what is the purpose of each material? Okay, obviously iron ore is how we're going to get iron. Coke, what is the role of coke? Coke is the source of carbon that will be used for reduction of the oxide. And then, of course, what is the role of the limestone? Now, if you're wondering what is limestone is calcium carbonate. It's a naturally occurring substance. Now, the role of limestone is to remove the silicon oxide. Silicon oxide is one of the major impurities that's found in the soil. It's often, sort of stuck inside your hematite, which is the iron ore, and we use the limestone to get it to react with the silicon oxide. The limestone, under temperature, it decomposes to give us calcium oxide. And this calcium oxide will then react with the silicon dioxide, which is the sand / soil, you can call it dirt that's mixed with your hematite to give us calcium silicate, SiO3. Calcium silicate, CaSiO3, is also known as slag, right? So what is the role of limestone? Is to remove impurities in the form of slag. What is the impurities that we're trying to remove with the limestone? It is this that I'm circling, silicon oxide. Okay, so you want to remember that. What's the next question? Okay, again, name the second liquid that's removed. We already talked about that. Up here is the same thing. When it solidifies, does it have any use? If so, this is slag. So they asked us to, the first question is where. I just realized that. This is name. So we have named it. It's the name is either slag or it's slag or calcium silicate. Now, calcium silicate has got a role. It is used in a building material. So as it used, so we can say it's a building material, or you can say road building. Okay, so road building is another answer that you'll find in textbook. I'm gonna write down here. It's getting messy there side. So name a waste gas from the furnace. So what is the waste gas that comes out of the furnace? It's carbon dioxide. This will be the major waste gas, but unfortunately there are also sometimes carbon monoxide. But these carbon monoxides are usually trapped and not allowed to be released because, again, carbon monoxide is a poisonous, toxic gas for humans. Does carbon dioxide particularly have a use? Now, the carbon dioxide as a gas itself, it doesn't have a use, but because it comes out really, really hot, so it's a hot waste gas. So hot waste gas in some country, it is used to warm the building. All right. So building especially in very cold country, building requires heating up. So they could actually channel back the gas into heating up their own building, or it's channeled back to go back into the ore itself. So you do not have to blast such a high temperature of hot air, or this hot air, you do not have to completely use energy to heat them up. If you're recycling the hot gas, it could be used for that purpose as well. So it's a form of recycling, and it helps reduce the cost. Explain why this is a reduction of the iron compound. Same thing, because iron oxide is going to lose oxygen to carbon to form iron and carbon monoxide. So you can see carbon is gaining oxygen, carbon is undergoing oxidation. Therefore, that answers the last question. Since carbon is undergoing oxidation, it behaves as the reducing agent. Okay. So with this, I think we have discussed all the important major component that we have. So I want you to dive into questions. That's at the back of the textbook. So those with the textbook, you can straight away refer to your textbook. I'm looking at page 184. Just the practice question. We can ignore the summary questions. The practice question in page 184 and page 185. I need you to answer them, and I need you to take a picture of your answer. If you have a scanner, you can scan it, and I need you to email it to me before 3 p.m. on Monday. I'm giving time till Monday, so this weekend, please put in a bit of effort, because I want to be able to go through all your answers and give you some comments before we move on to next week's lesson. So next week, Wednesday, I'll be giving you some comment about your answers, and then I'm going to start chapter 15. Chapter 15 is actually quite an easy and fun chapter. The chapter is called Air and Water. So hopefully before school opens, we could at least cover up to chapter 16. And of course, I'll be giving you a quiz/test through Google Classroom once we have covered chapter 14 and 15. So that should help you revise more diligently. Okay, all right, that's it. That's the end of the lesson. Please drop questions that you have into the comment section of Google Classroom, or you can drop the question in our Telegram group, and I'll respond to it as soon as I can. Thank you very much.